Hey there, Algebra 1. So we're going to go ahead, we're going to look at choosing some methods. So we're going to choosing the most, I'm going to underline that, appropriate method to solve quadratics. So over the past few weeks, we've been working with a few different methods, and now we're going to go ahead, we're going to say, hey, I have a quadratic, I need to choose the best one to solve this. So we started off this whole thing by talking about factoring. And when we were factoring, our first step, of course, was to set equal to 0. Then we wanted to factor our quadratic. And then we would use zero product property. To solve the quadratic. So if I'm looking at some example for this guy, I would have a quadratic that would look like x squared minus 4x minus 45 is equal to 0. And the first things I'm going to go ahead and do is set up this little x guy over on the side to see if I can factor it. So I would look up negative 45, negative 4. Well, duh, Miss Lawrence, I got negative 9 and a positive 5. And absolutely, I love this because you can just go ahead and set up x minus 9 times x plus 5 is equal to 0. And this is when that cool zero product property rule comes in. So you either have this guy, your blue guy, or your orange set over here, some Mets colors for you today, and you would say that x minus 9 equals 0, or of course, you could say that x plus 5 equals 0, solving both of these options, meaning that your first answer is x is equal to 9, and your other option is that x is equal to negative 5. So that would be solving by factoring. And this is great if the problem is factorable. So if we're talking a little bit about our pro-cons here, is that must be able to factor. So definitely it has to be factorable. And it doesn't work here, so can only be used if the problem is factorable. So only be used sometimes. So if it can't be factored, it means you can't use this method. But that's okay. We have a few different methods that we were working with. I'll switch to purple. That's a good one. Okay, so then we were working with our quadratics and we said, well, we have this cool method called square roots. And when we were working with square roots, we said, okay, well, it has to be in this form, meaning that ax squared plus c has to be in this form here with no bx term or no middle term there. Or it has to look like this. A plus b quantities squared is equal to a number where the square is isolated. So it has to be kind of in these two terms for our square roots to work. So I actually have two examples for you on this one. And I kind of like these square roots because they actually are pretty similar to solving our linear equations, where we go ahead and we look to isolate your square. And I'm going to do that by adding 18 So we get 2x squared is equal to 18, and then divide by 2. So x squared is equal to 9. And this is where that square root comes in, because we have to take the square root of both sides, and then we have to make sure that we add that plus or minus sign. So definitely plus or minus sign. Don't forget that guy over there on the final answer. And as promised, example number 2 here is x minus 2 squared minus 7 equals 0. And this is where we have to isolate this whole entire thing before we take the square root. So we have x minus 2 squared is equal to 7. Then we're able to square root it. And we get a little bit of an extra, hey, there's that plus or minus, right? Of an extra step here, and that is that you have to also add 2 to isolate your x at the end, meaning that x is equal to 2 plus or minus the square root of 7 for my final answer. And I'm going to go ahead, I'm going to box this guy, and as we remind ourselves, those are 2 answers right there. And this guy is also 2 answers over here on the other side, so we're going to box them. Now, of course, it can only be used, I'm going to say our pro-cons over here, is that only used in certain situations. So only used when you can isolate the square. So there's some situations where you cannot use this guy. But never fear, we have a few more options for you. Now this whole past week, we were working on my favorite, completing the square. Love this guy. Completing the square. And the cool thing is that it always works. Any problem, you can go ahead, you can use this. But it's best used when a is equal to 1, so meaning that you have something like x squared plus bx plus c, and the b is even. So this is the best situation to use this. So I'm going to go ahead, I'm going to give you the example for this guy, and we would have something like 2x squared, oopsies, plus 12x minus 24 is equal to 0. Okay, so I got to make that leading coefficient 1, meaning that I need to go ahead, I need to divide everything in this by 2, leaving me with x squared plus 6x minus 12 is equal to 0. Now, here's one of the other cool things about why I chose completing the square for this guy, and that is because c is pretty big. And when c gets pretty big, meaning it's a big number, it's a little bit hard to use the quadratic formula without a calculator. So I like to complete the square on this. We got to start by adding c to the other side and leaving ourselves a little bit of room to do that cool complete the square. Now, on this guy, we're going to add half of b squared. And if you add something to one side, you, of course, have to add it to the other side, leaving us with x squared plus 6x plus 6 over 2 is 3. 3 squared is 9. Add 9 to the other side. And I'm going to factor now. If you remembered that 3 there, you can go ahead and plug that into your perfect square trinomial. And then 12 plus 9 gives us 21. Now it just turns into a square root problem. I get to square root both sides. X plus 3 is equal to the positive and negative 21. I'm going to check to see I can't simplify that root anymore. which I can't, so I leave my answer as -3 plus or minus the square root of 21, because I like to leave that integer out front. And I'm going to box it because that's my final two answers there. Don't forget, those means two answers. That is it. So let's look at our little pros or cons for this guy. So our pros or cons, of course, is that it can always be used. All right, but sometimes results in some fractions. So easiest when A is equal to 1 and B is even. So easiest when that happens, so meaning that if you don't have that, I probably wouldn't use completing the square. Okay, we are on to our last one here, and I kind of call this last resort, even though it seems to be some people's favorites, and that is the famous quadratic formula. I'm going to even give it an exclamation point. Now this buddy always works, but you definitely have to make sure it's set equal to 0 first. Equal to 0. And for sure, I'm going to go ahead and have you guys write it again, meaning that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Heck yes, that's our quadratic formula. So let's work with our example on this guy. So I would have 2x squared plus x minus 5 is equal to 0. Now, some of the things I'm going to check in about is that if I tried to factor this, meaning that if I tried to take -5 times 2, so that's 10, sorry, -10, and then -10, there's no factors that would add to 1. So I can't factor it. And if I went ahead and I tried to divide this by 2 to complete the square, I would end up with fractions. So I don't want to complete the square. That leaves us with our quadratic formula. And it's always a good idea to go ahead and state, oopsies, let's go back to our pencil. State what A, B, and C are equal to. So A is equal to 2, B is equal to 1, and C is equal to -5. From here, it's pretty easy to plug in those values. So I have -1 plus or minus the square root of 1 squared minus 4 times 2 times -5 all over 2 times 1. Now, you guys might be getting pros at solving these, but I'm going to go ahead, I'm going to do it step by step here. So I have -1 plus or minus, I got 1, and then I have this -4 times 2 times -5. Got a negative times a negative in there. That's going to end up with a positive 40 all over 2, meaning that my final answer for this guy is -1 plus or minus the square root of 41, check to see if that can be simplified, it can't, over 2. And boxing it to make sure that I know that's my final answer. And then let's talk a little bit about our pros and cons. So always, always, always a way to use. So always can be used. Definitely. Always. Now, you want to make sure that as the numbers get bigger, it's a little bit harder to do, but it's a good idea to use as a last resort. So try the other 4, before you try your quadratic formula. Very nice job. You guys are all done.